Hello and welcome. Today, we are going to break down two fundamental concepts in thermodynamics, QH and QL. If you've ever been curious about the science behind how a car engine runs or how your refrigerator works, understanding these two terms is the perfect place to start. Let's begin with the letters themselves. In physics, the letter Q is used to represent heat transfer. The H simply stands for high temperature, and the L stands for low temperature. So, QH is the heat transferred from a high-temperature source, and QL is the heat transferred to a low-temperature source. Think of them as heat high and heat low. Now, let's apply this to a heat engine, like the one in a car. A heat engine's job is to take heat and convert it into useful work. To do this, it must absorb heat from a hot place. This input heat is QH. For a car, this comes from the controlled combustion of fuel, which creates a very high-temperature environment. This QH is the total energy the engine gets to play with. However, a crucial rule in thermodynamics, the second law, states that no engine can be 100% efficient. It's impossible to convert all the input heat into work. Some of that heat must be discarded. This rejected or waste heat is QL. It is transferred to a low-temperature reservoir, which is usually the surrounding air. In a car, this happens through the exhaust system and the radiator. The actual useful work, which we can call W, is what's left over. The core relationship for a heat engine is work equals QH QL. You take in heat, you lose some waste heat, and the difference is the work you get. Now, let's see how this works for a refrigerator or an air conditioner. Here, the process is essentially reversed. The goal isn't to get work out, but to use work to move heat. Your fridge's purpose is to remove heat from the cold space inside it. The heat that is successfully removed from the inside of the fridge is QL. But heat doesn't naturally flow from a cold place to a hot place. You need to force it to move. This requires an input of work, which is provided by the refrigerator's compressor using electricity. This work energy, combined with the heat, QL, taken from inside, is then expelled into the warmer room as QH. You can feel this as the warm air coming from the coils on the back of your fridge. For a refrigerator, the formula is QH equals QL plus W. So, in summary, for a heat engine, QH is the energy source and QL is the waste. For a refrigerator, QL is the desired heat removal, and QH is the total heat exhausted into the room. It all depends on whether you are using heat to create work, or using work to move heat. Thank you so much for watching. I hope this explanation made QH and QL a little clearer. If you found this video helpful, please hit the like button and consider subscribing for more simple science breakdowns. If you have any questions or ideas for future topics, leave them in the comments below. We'll see you next time.